There's a very interesting question about litmus test. Actually, the use of litmus test is just to check whether it is an acid, a base, or a salt. Now, it's a very interesting question. Suppose you have just red litmus paper. And you have 3 test tubes in which A, B, C chemicals are filled. And you are told that one contains an acid, one contains a base, and one contains a salt. And you have to identify which of the test tube contains what. You just have red litmus paper with you, you don't have anything else. So what would you do? Now, we know that acid will change red litmus paper to blue. That much we know. And base will change red litmus paper to blue, and acid will not do anything to the red litmus paper. So, and also the salt will also not affect the red litmus paper. So only one out of these 3 will change the red litmus paper to blue. Now take the red litmus paper and put it in all the 3 solutions one by one. First put it in solution A. If nothing happens, that means A is not the base. And if it changes to blue, that means A has to be the base. Now, if it changes to blue, you know that this is the base. No need to dip it again in B and C. But out of B and C, which is the acid, that we have to determine. Now what has happened, that this red litmus paper has changed to blue. So now this red litmus has actually become blue litmus paper. You dip it in a base, it changes to blue, and you get blue litmus paper. Now an acid will change the blue litmus paper to red, and we need to determine which out of B and C is the acid. So you take the blue litmus paper and put it in both the solutions. One of them will not affect the blue litmus paper. Suppose C does not affect the blue litmus paper, and B will obviously change it to red. So B will be our acid. And since C did not do anything to the red litmus and did not do anything to the blue litmus also, so C will be our salt. So just by one red litmus we can identify all A, B and C. Now let us proceed to the reactions. Firstly, we will see reactions with metals. Now acids, suppose we know that HCl is an acid, hydrochloric acid. We have HCl, and suppose we have a test tube full of HCl. And we add some zinc pieces to the test tube. then what will happen? You will see that as you add the pieces to the test tube, there will be a fizzling sort of sound, there will be a reaction, and then a colorless gas will be evolved. And if you take that gas through a pipe and then pass it through water, you'll see that bubbles will evolve, and the bubbles will be obviously containing this gas which has evolved from here. And if you take a burning candle or a burning matchstick near that bubble will explode. So you take a test tube of HCl, you add a zinc piece or few zinc pieces, and there is a fizzling sort of sound, and then the zinc piece actually dissolves in the acid, and then a gas is evolved. And that gas, if you pass through water, make bubbles out of it and bring a lighted matchstick or a lighted candle near it, that bubble will explode. That means that the gas inside the bubble is combustible. The gas inside the bubble will ignite on bringing this matchstick towards the bubble. So you have HCl and you have added zinc to it. This will give you zinc chloride, that is ZnCl2, and the gas which was evolved was hydrogen. And we know hydrogen is combustible, so that proves our equation. So this metal, this is just a metal, and it has reacted with an acid, and this metal came and knocked this hydrogen out. That means it displaced the hydrogen of the acid, and it made zinc chloride. And if you balance this reaction, the balanced reaction will be this, just this. So when a metal will react with an acid, it will give a salt of that metal plus hydrogen gas. A metal reaction with an acid will always lead to the evolution of hydrogen gas. Not all metals, but few metals, quite some metals. Actually, there is a reactivity series, and it says that the metal which is above hydrogen in the reactivity series will displace hydrogen to make its salt.